Hi, my name is Yu. Today I'm gonna do my presentation, and my topic is the chemistry behind vinegar. Well, when you think about vinegar, you might be thinking about like kitchen or cooking. But do you know that vinegar can also be used in labs or be used in experiments? The formula for vinegar is CH3COH, water and trace amount of other chemicals, which may include flavoring. The acetic acid is variable. Distilled vinegar contains 5 to 8 acetic acid. The difference between different vinegar, like cooking vinegar or cleaning vinegar, only difference in its acidity. To put acetic acid into a more simple term, it just means the sour taste within the vinegar. For example, if you have a 5% acidity vinegar, it's more likely to be sour than a 4% vinegar. So in this video, I'm gonna do 3 different experiments to show what vinegar does. So the first experiment is combining baking soda with vinegar. The second one, I'm gonna put an eggshell within the vinegar. And then for the third one, I'm gonna put a penny in the vinegar to see what will happen if these things combine together. So now, I'm gonna start the first experiment to see what happens if vinegar is combined with baking soda. So for this project, we're gonna need vinegar, a glass, a bag to contain the baking soda, and baking soda itself. So now I'm gonna do the experiment. Oh boy. As you can see, there's a lot of bubbles going up, and the water from here all the way right to here, and now my table's all wet now. Yay! So after finishing the first experiment, I noticed that I ran out of the white vinegar, which has a 5% acidity. So instead of that one, I'll be using the rice vinegar, which contains 4.5 acidity. So we're just gonna test out whether there's a difference or not. So now instead of the white vinegar, I'm pouring some of this rice vinegar. So now we're gonna do the exact same experiment, but only this time with rice vinegar. As you can see, there's not that big of a difference since there's still a lot of bubbles and the water level rise up just like the white vinegar. So from this, we can conclude that there's not that many difference between the white vinegar and the rice vinegar, even though there's a 0.5 acidity difference. So what do we learn from this experiment? As you can see, the end result has a lot of bubble, and that is because after the vinegar and the baking soda combine, one of the products of this reaction is the carbon dioxide, and that's what makes the bubbles. To be more specific, is the hydrogen ions in the vinegar reacts with the sodium ions in the baking soda that creates this kind of reaction. That's why if you mix water with baking soda, it won't work. Let's think farther. If I use vinegar and baking soda to create this kind of colorless bubbles, what will happen if I add colors into it? For example, what if I add red, green, blue food coloring into it? Wouldn't it be cool to have colors? As you can see, these are all the products that were created with this experiment, and adding food coloring can make it look better. And this is how people make fake volcanoes. Alright, let's move on to the next project. For this project, we're going to be using an eggshell, a glass, and the vinegar. And we're going to see how long would it take for the eggshell to dissolve in the vinegar. And since this is an experiment, I'm going to use a maximum of 3 days to test out whether it will completely dissolve or not. If it went beyond 3 days, I'm just going to see what will the eggshell turn out. As you can see, I've already put in the eggshell, and the reason why I set the time to 3 days because according to the online resources, the eggshell is supposed to dissolve within 24 hours to 3 days. So I'm gonna see if this eggshell does the same thing as what they said. Alright, it's been an hour. As you can see, there's a lot of bubbles. It has been another hour. As you can see, the outer layer of the egg is starting to dissolve. So, as you can see, the egg really didn't change that much. There's still bubbles, but the thing isn't dissolving. If I try to press down the egg, it will immediately pop up. Right now, so it has been a while, so it's been another day, so I'm gonna check it. The eggshell is broken. You can see the inner layer of the thing, but there's not, like, the outer layer is still there. It didn't dissolve, so I'm gonna pour it and see what has happened to it, and whether, like, what did the vinegar do to it. As you can see, I can easily peel out the inner layer of the egg, and when I try to touch the outer layer, it's still very hard. It will still make a cracking noise compared to what I was expecting. And I was able to peel out the entire inner layer within a piece. So, what did we learn in this project? The eggshells contains the calcium carbonate, which reacts with an acid in vinegar called acetic acid, like we previously mentioned. The acetic acid breaks off the calcium and carbonate, dissolving the shell. While the calcium floats away, the carbonate reacts with acetic acid to create carbon dioxide. This is why we see bubbles on and around the egg. Although, according to experiments and the internet, the eggshell is supposed to dissolve within 24 hours to 3 days. However, when I'm doing the experiment, it wasn't able to dissolve within 3 days. So what happened? My hypothesis is that it didn't work because first, the acidity of the vinegar isn't as high as what others has been doing. Maybe that's one of the reasons why it didn't work. Alright, let's move on to our last experiment. For the last experiment, I'm gonna use vinegar, a penny, and a water bottle cap. So what I'm gonna do is I'm gonna pour in the vinegar into the cap that contains a penny in it, and I'm gonna see the reactions and what's gonna happen. So as you can see, 1 hour has passed and there's not that many noticeable changes to the pennies. If you really want to look closely, there's a little green spot to the right of the penny, and that's about it. Alright, so a day has passed, and as you can see, the penny has turned very dull and the vinegar becomes greenish. And as you see very closely, you can barely identify the penny itself, and it's very dusty now. So, what might cause this reaction, you may ask? And this is because the hydrochloric acid produced by the vinegar dissolves a thin layer of copper on the penny, repeatedly allowing copper oxide to form, and cleaning it will slowly but surely reveal a quick to dissolve zinc core. So, what did we learn from all three of these experiments? What can we conclude about vinegar? So, number one, all three of these experiments are chemical changes since they cannot be reversed. For example, the penny cannot be turned back to what it used to be. Second, we get to learn that the acid within the vinegar can do a lot of stuff. For example, it can dissolve eggshells. So with that knowledge, we can apply it to real life. For example, if you want to clean your window, you can put in some vinegar within the water, and then you can wipe it on the window and it will make it cleaner. At the end of this video, I want to talk about some other effects vinegar has outside of these 3 experiments. Number 1, vinegar can appetize and will help digestion and absorption. Second, vinegar has a good antibacterial effect which can effectively prevent diseases. And lastly, vinegar can play a very good role in sobering up people after alcohol, since it can reduce the concentration of alcohol. And that's it. Thank you guys for watching. If you have any questions, just ask me.